Hi guys. Happy Friday. I apologize. I'm a little tired as I do this, but we're going to get through this. I'm going to try and do as clear as possible. The first question for homework, excuse me, was I have to sneeze. 1.7b. So that's what this is from 1.7. Again, these are all for free response number 4. This is one we've seen a lot. Chlorine gas, blah, 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 solution, potassium bromide. So we see neutral atoms, so redox is going to have to happen. This is going to go, this is going to go down to Cl minus. Bromine is going to go up to the bromine Twinkie, and potassium is going to stay the same. It is the spectator ion. We are left with Cl minus, 2 of those Br20, 2 of those. The oxidation number of chlorine before is Cl20, and the oxidation of chlorine after is Cl minus. Chlorine was reduced in this case, which makes it the oxidizing agent. This is something that we will refer to a lot in the next unit. If you have seemed to soak it in this unit, you're just ahead of the game. The next one, solid strontium hydroxide. Okay, so it's 2 plus OH minus, but we're going to represent it as CrOH2 because it's not in water, is added to a solution of nitric acid. This is how you write nitric acid, H plus NO3. We see ions. There's no neutral atoms, so it's not going to be redox. So if there's no neutral, no redox. Alright, so we're just going to have a swap. It still can swap. In this case, there is water. Water is present here. So there is the potential of having ions in the product side. Sr2 plus is going to be with the nitrate from here and from here. Nitrates are always soluble, and there is our stick. The H is going to go with the OH. So this is from the stick box. Going to cancel our spectators. We see the nitrate is a spectator on this side. Nitrate is a spectator on this side. The Sr looks different on both sides. The OH looks different. Everything is different. So our final balanced reaction is SrOH2, H plus goes to Sr2 plus HOH. We're going to put a 2 there because the 2 H's here, which means we're going to have to put a 2 there. Okay? I'm going to rewrite this because it's going to help out in this next part. Okay, you do not have to know how to do this one. Okay, do not have to know how to do this one, but if you know how to do it, it's going to make our lives in the next coming month a lot better. It says how many moles, so how many moles of strontium hydroxide would react completely with 500 milliliters of 0.4 molar nitric acid. For those of you that did not have molarity last year, this is the equivalent of saying 0.2 moles. So if you had 0.2 moles of the nitric acid, which is the H plus in this case, how many moles of strontium hydroxide would be required? Okay, this is actually really, really simple if you look at it. For every 1 mole of strontium hydroxide, you need double the amount of acid, of H plus. So if you have 0.2 moles of acid, H plus, I'm going to give you guys about 10 seconds to figure out how many moles of strontium hydroxide you would need. exactly. If 2 is to 1, as 0.2 would be to 0.1. So 0.1 moles of strontium hydroxide would be required to fully react with 2 moles or 0.2 moles of the acid. So that was 1.7. This was 1.7 B. This was 1.9 B. And now we are going to do 1.9 C, just the first one. So a solution of barium chloride, so we have Ba2 plus Cl minus, is added drop by drop to a solution of sodium carbonate. Na plus CO3 2 minus. Okay, we see ions, so we're going to swap. We're going to stick. We know that sodium is an alkaline metal. It's always soluble. This is our stick. Ca minus, Cl minus, Na plus Ba CO3. We are going to get rid Na, spectator, Cl, it's a spectator, and we are going to rewrite the reaction. Ba2 plus CO3 2 minus goes to BaCO3. Give you guys about 5 seconds to think about how you would categorize this reaction. Okay, we made a precipitate. So we could call this reaction in general double replacement, and the specific type of general replacement is called precipitation. Have a great weekend, everybody.